Okay, so we come to section 1.2, domain and range. So in the previous section, I did mention about domain and range. They are all in a function, right? A function have all the value of input, which is domain, and all the value of output, which is range. So and you also see over here, I have a graph of function f of x, right? It's come from this point. Let me use, it's come from this point over here to this point over here, right? It's like a curve, right? Okay, so if you look at it graphically, how can you know what is the domain and what's the range? So you see, using the red, let me say pink one is the domain over here. We actually is how horizontal the graph can go, right? How horizontal the graph can go. So it's in between, let's say A to B here, right? So here's A, is B. See that, right? So domain gonna be in between A to B. Okay, so for the range, right? So let's change this color to be red. All right. For the range, I would say the graph, as you see, right, it starts from here and as the lowest, and I just move vertically. I go up to maximum gonna be here. All right. I know it's go down later, but I know that it's just maximum vertically gonna be up to here. So that means the range is how vertical it's going, right? As you see from here up to here, right? Range is how vertical it goes. How vertical it goes. Yeah. So is using the green one. So then the range, I want to say in between f of A to f of B. So here is f of A and here is f of B. Okay. Oh no, it's not F of B, sorry. Now let's not using C here. Here as C. F of C. Okay, so this come to C on it, all right? Because F of B is this guy, but I know the maximum was up to here. So, all right. So that is graphical way, all right? So let's take a look at exercise 1.3 here. And according to the definition of domain and range, let's we go ahead and work on this follow, okay? So I did show you the graphically, so go ahead and work on the right one over here. Okay, so let's pause my videos and tell me what is the domain, right? And then let me know the answer. Okay, go ahead and pause my video. So I hope everyone did notice that for the domain is come from the low. I mean, domain is how horizontal it go, right? So it's come from the lowest horizontal was 2. So and then is go up to 5 as I draw in the figure there, right? So that means from 2 to 5. And the notations I use gonna be the brackets, which is from 2 and then comma to 5, and then bracket. So bracket is stand for inclusive. Okay, so bracket is stand for inclusive. All right, so or another way to write in not in the interval notation, in inquiry notation, I'm gonna say x is in between 2 and 5. So both is answer. Okay. For the range, I will go ahead. You can go ahead and pause my video and try it. Okay, make sure it was a vertical checking, right? So the vertical lowest value will be this one. So I will go ahead and draw it. And the vertical highest gonna be this point over here. Okay. So as you can see now, I will just going probably, okay, let's see, maybe I have to using this one. Range here. So it's come from, I would say here's a negative 1.1. And go up to 9. So inclusive, right? Because it includes up to there. Okay. Another way to write in inquiries, you can write as y is in between negative 1.1 to 9 equals like equal sign. So both answer should be okay to me. Okay. So okay, so now let's move to the left exercise, right? Keep in mind that now I have 2 circles, right? And it's mapped to another, I mean, one circle on the left mapped to another circle from the, not a circle, let's say like ellipse, to the right ellipse. And look like the first ellipse is name of students, and the second ellipse is the grade, right? Letter grade, right? So So I would say domain, since domain is all possible input, right? So I will have to write down all possible input in here, which is Kali, right? Lila, right? Bear, Rookie, Tan, Mariana, Philip, Bruno, and Jeddah. Because and the range is the value that's the input map to. So we is a order, we is a gray letters there, right? So I have A, I have A minus, I have B plus, I have B, I have B minus, I have C plus, I have C, I have C minus, and I have D plus, I have D, and F. Sometimes it's the output become duplicate there, but it's it should be okay. But in this case, we don't have any duplicate one, right? We have Tan and Bruno, they have the same great letters, but again, two input make one output still a function. So this is still good, right? Since function, then you can have domain and range. Okay. So yeah, so so this is about domain and range exercise. Let's move down. Okay, so we're gonna try to find the domain and range of the function y equals to square root of x. Okay, so I don't really need to I mean, you don't really require to graph is carefully perfectly in this case, but in order to graph like y equals square root of x, you can make like a t tables with the first the left hand side is for x value and the right hand side is for y values equal to square root of x. All right, so try to put some value for x that first define, secondly easy for you to make a square root, right? So so you don't want to make a value that's less than 0. You don't want to make a negative value for x, right? You must make it greater than or equal to 0 to make it define, and then that is make imaginary number, right? So you must start from 0. Let's say that, right? So square root of 0 is 0. No worry. Okay, so another one could be like 1. Square root of 1 is still 1. Maybe if you think about 2, I don't think that's gonna be a good idea. So choose 4, make 2, right? And maybe the last one could be number 9. And square root of 9 is 3, right? So you will go ahead and input. I know actually let's just pollinate it. So this make a connect as 0, 0, 1, 1, 4, 2, 9, 3. All right. So you will have to coordinate this point, right? I know that's 0, 0 when we start from here. 1. Okay, so that means X values is 1, Y value is 1 also. So one more part here. And then 4, 2, so 4, 2, okay. 9, 3, 9, 3. Okay. And then you draw the graph. Not a perfect one, but you know, that's what it is. So, as you see right now, if I want to find the domain, right, which is the whole value of X, or the value of input, like how horizontal it go. Okay, you can see that X will never greater than X will never less than 0, right? And you can see that the domain domain must be just from 0 and up to infinity, right? Because how horizontal it go, right? So domain is going to be from 0 inclusive, right? And up to, so comma, post infinity. And you see put infinity, you cannot make inclusive, so you must make an parenthesis, right? So like exclusive, opens, open bracket. Okay. So this is this means that X greater than or equal to 0. Okay. So so this by using interval notation and inequality notation. Okay. So what about the range? You know, the range is that also from 0 here. And look like right now we go up to 3, right? However, think about if I keep make it farther and farther, right? Keep make it farther and farther. So it can keep going up and up. So that's, I would say, is keep going until positive infinity. Right? So that means how vertical it go? Gonna be the range is start from 0 and up to positive infinity. And if you want to write the inequality notation, you write y greater than or equal to 0. Maybe I write like this better. Let's see. Let me change this. Give me 1 second. So I write as y in between 0 and positivity, but not includes infinity. And X is in between 0 to positive infinity, but not includes positive infinity. Okay, so yeah, so that is, for example, 1.5. Okay, so keep you can go ahead and try 1.4 and tell me the domain and range of the function y equal to 2 minus x. So keep in mind that you may have think about you need this one not gonna be negative. So make sure that you may not input something like less greater than 2, right? And you see the graph over here, right? Okay, so I would like to leave this for you to input the domain and range, right? But the answer key you can write as negative infinity to 2. Actually, this should be enough since you see the graph already, right? You see the graph was just from 2 here and now to the negative t here. So you step like horizontally step from negative infinity, but not inclusive, and go up to 2, right? But for the vertically, right? Vertically is, yeah, is step from lower one from this point, right? Was 0 there, and it's keep going maybe up to here. But if you keep farther to the left, it's keep going up. So the range must be from 0 to positive infinity. And I make a mistake here, which is 0 must be inclusive, right? Okay, so we're gonna go ahead and move to the next problem. Now, let's make is more text in your major. Most of you is about business people. You talk about cost. We talk about business things, right? So let's we think about electricity cost. So let's we using example 16 here. And we suppose that the cost functions of the electricity can be described by E of K equal to 14 plus 0.1 or 0.10 K. So where K is measured in kilowatts per hours, right? Kilowatt hours. And E of K is the cost of using K kilowatts, right? Using K kilowatts. So let me maybe see here to make sure you don't mess up with that. And we want to ask what is the domain and range of E of K. So I would like to start with using okay, actually, you know what, we're gonna need to think about what is smallest of K in here, right? Because we since we talk about domain, so let's highlight here domain. And since we talk about range, right? So domain, in order to find the domain, what is smallest? K can be, right? Input in here is K, right? So what is smallest K can be in the real life? Okay, what do you think? 0, right? I mean, if you don't use anything, it's 0. It cannot be negative number. So I would say 0. Right? So then I would say for the smallest, oops, give me 1 second. So what is smallest? K in here is 0, right? And since you had smaller, if you don't use, right, how much you have to pay, right? Is smallest cost. Smallest cost. E, okay. E of 0. E of 0. So that's going to be equal to what? 14 plus 0.10 times 0, which is 14. And what is maximum, right? What's the largest? Largest K can be. I mean, you can think like you can use as much as you can. So there's no minimum. I mean, there's no limit in here. So I would say like positive infinity, right? And you will say, oh, then the largest cost will be E of infinity, which also gonna be infinity. Since I mean 14 plus something, 14 plus infinity will be just infinity, like maximum. I mean, it's just a big number. So let me separate this. So now we can make a conclusion for the domain. Right? Domain is the value for K, right? Or the input value for K. K is come from zeros. So K is come from 0 and up to infinity, right? Minimum and maximum there. Sure. Right? Or in the interval notation, you can say like 0 and comma post infinity and parenthesis there. So now for the range, what's the minimum for E of K? So E of K, what's the minimum can be? 14, right? You don't use, you still have to pay. That's because that's like a base cost. And you go up to positive infinity. All right. So in the interval notation, you can write as 14 and up to positive infinity. All right. So that is reality that you, I mean, if you look at, let me show you by using Desmos. So Desmos. Okay. So in Desmos, well, I know that they don't want to accept is of K. So maybe we're gonna use E of X here, and that equal to 14.00 plus with 0.10x. It doesn't look like, let's see. Yeah. So let me see. Okay. So here is the line that we have from the Desmos. but there's some, I mean, if you say only these two, you input the function into the Desmos graph, it just show you the whole graph, and there's no limit at all. And you see there's some negative here, right? And honestly, in the real life, we don't care about the negative side at all, right? Because you don't have like value of k equal to negative in here at all. So you may have to adjust the x values must be start from 0. I would say that, right? To make it, look nicer, or you can make it like from negative, let's say -1, to make this, there's some thing that you can still see, but you don't care about the negative things, right? You just start from here, right? Okay, but again, that is the real line, considering, okay, but come back with the problems there. If we think about it, there's no limit, okay? Let's like, sometime the domain and range are limited by the applications, as the case above. But and we now can compare the two scenarios. So let's move down a little bit here. Okay, so you can see the way without limit here, that domain is all like all real number. See, it's just all the way from the left to all the way to the right, right? So I mean, this is a equation y equal to 14 plus 0.1x. Okay, we graph y equals to 14 by 0.1x, and you got this graph function. So domain will be just from -infinity to +infinity. And similarly, the range also, right now it's look like you come from like 12 here, like the lowest vertical was 12, and the highest going to be like 16. But look at that, it's keep going down and up. See, you zoom out, and absolutely you did see from Desmos, right? Let's go from -infinity to +infinity. So I would say this is the range for this going to be from -infinity to +infinity. And for the functions that we use from application above, is k equal to 14 plus with 0.10k, will give us the domain is changed just from 14 to up to +infinity, and also the range is changed from, I mean, the domain, it comes from 0 to, I should move this down a bit, sure, 0 to +infinity, right? Domain 0 to +infinity, right? And the range is just from 14 and up to +infinity. inclusive. Okay. So so we change domain and range when we have application problem. All right. Okay, so let's move down. Keep in mind, this is important. In this course, we usually consider only positive domain and range. All right. Like, you know, this is application, so it's real. You don't want to think about, oh, there's a negative value that you want to use for electricities, right? So it's really positive. All right, so now we're gonna move to the next exercise. And okay. So I would like to let you guys think about doing this exercise and working on that. Okay. So what is the minimum number, right, of calculators? So these is calculator problems. I mean, calculator companies that make calculators, and they have the cost functions. We produce X calculators per day, right? The word per day is over here, right? So every day it's produced X calculators. Uh-oh. Something questions. Oh, come on. I lost everything. Okay, that's fine. All right, so you have to know that it was X calculator per day, and think about what is the minimum number of calculator to produce each day, right? This is real life problem. This is application, right? Think about if the company doesn't like have one day off, what's the minimum number of calculators can produce? Think about that, right? And since that, then you move to B, say we assume that calculators can produce a maximum. So right now you are given the maximum capacities always is 1,000 calculators per day. So that will be the X max, right? So and so then I will go ahead and put out this X mean to 0, and from here I have X max equal to 1,000. So domains will be in between X mean and X max is 0 and up to 1,000. in between. Okay. Or maybe another way to write as x in between 0 and 1,000. Yes, okay. Then I will try to find the minimum value of the cost, right? It is a case when you don't produce anything. So a C of 0 is 250 plus with 2 times 0. That's given you at 250. Okay, and we also call it is a fixed cost. And you will see it's more later in this class. Okay, it is fixed cost. Since no calculators are produced, and we still have costs, so then we call it is a fixed cost. And with the maximum capacities of X 1,000 there, we're gonna have the maximum cost as C of 1,000. So we're gonna substitute 250 plus 2 times 1,000 here. All right. Use a calculator, you should have 2,250. Right. The box is to make sure. Okay, so now we're gonna using the result from C and D that means the range gonna be what? Okay, so the range is the value of C of X, which is in between from where to where. Let's go ahead and put it. So in this case, we have 250 to 2,250. Okay, now what about this a case that I consider the price function? No, not so. This is not the function of the cost. It is a function of the price. Okay, so price function. The function is p of x equal to 2 minus 0.5x. Yeah, so this is a different function. Okay, it is a function of the price. I'm gonna talk more about the price function later in the next section or something. Okay, so these price functions as we produce more calculators, so more calculators, the price of each calculator go down. Okay. Right. Since you have so many calculators, you then then the price of each calculators will go down. So we're gonna find the fixed price when producing no calculators first. As you also know that the minimum of X is 0, right? So if you want to find the fixed price or the minimum price, so you're gonna just substitute X equal to 0 into the function of price. So in here, I will go ahead and substitute as 2 500ths minus 0.5 times with 0. That's giving us only 2,500ths. My box has. Or you can say like it is minimum price. Okay. Think about the price when you produce the maximum number of calculators. So P of 1,000. So you're gonna be gonna be 2,500 minus 0.5x. No, actually, no more x. Is changed to be 1,000. The input now is 1,000. And you get P 1,000 will be equal to 2,500 minus 0.5 thousand here going to be another 500. So that's going to be 2,500 minus 4,500 equal to 2,000. No, actually, so this is it actually is this actually gonna be the minimum price when you produce thousands calculators. So I'm not using the word minimum price for the fixed price, since it's higher than the price when in the case you have like 1,000 calculators. But you know that it means that the price just gonna stay in between 2,000 and 2,500 only. So the range for this function will be in between. You want to write the smaller one first, 2,000 to 2,500. And in the interval notation, you can write 2,000 bracket, right, comma 2,500. Up here I forgot to write. So from 250 to 250. Right. All right. Okay, so let's move down and talk. And now we're going to talk about a revenue. So we did talk about what? We did talk about cost functions. All right. We did talk about revenue function. I mean, sorry, price function. Right. So let we did have a problem to talk about a cost function here. Right. The cost function is a line increasing, right? And the price functions here is a line, also a line decreasing. There's a case that we have price function gonna be increasing, but I'm gonna talk about that later in some chapter later. Okay, but for now, just keep in mind that price function and cost function, they both a function of line or linear function. Now let's talk about revenues. What is the revenues? So I have definition of revenue in here. I mean, most of you in here in this class are business people, right? So I'm just gonna give you the definition like a rough things as revenues is all the gross sales, right? And note that it is not a net amount. It does not take into account the cost going out. Yeah. So let's do an exercise. So Rosebud Limited companies sells snow sleds, right? And the revenues in dollars for selling X snow sleds is Rx equal to X times X minus 100. And here's a graph of the revenue function. I mean, you can also graph this function on the decimal if you like. Let me show you. All right. So hold this one equal to X times X minus. All right, so as you see here, all right. All right. Something was incorrect. Let me see. I think something was incorrect. Supposed to be negative here. All right. Yes, this is supposed to be negative. Okay. So this is supposed to be negative. Typo. Okay. Let's typo here. Make sure. All right. Yeah. So, and you can see now. So yeah, you can see right now, if you are like an accountant in the companies and you show the boss with this function, well, it is a correct function, but the thing in here is doesn't make sense, right? You don't need the negative thing at all, right? So I would say you don't want to need to have the negative thing here. So you will, I would say the horizontal, I mean the vertical one, you would just start from maybe -1 here. All right, and up to like 2500 here is maximum. So I'm gonna make a little bit, you know, batted it up to 2765, something like that, right? So that's look good. For the X value, I may have to change. Okay, so I may start from -1. And I just gonna go up to, okay, so I need to take a look at values. They don't have, they don't say what is maximum of the item of the X snow less, right? What's the capacity of that? But and you can see like we have the function will be 0 at hundreds here. The function will be 0, start from 0 and going out, and the values keep down after like 50 here, and keep going down and down until when X equal to hundreds, the Y value of the revenues becomes 0. So that means after this, it's gonna go down to negative. So we don't care about after x greater than 100. We just care about from 0 to 100 on. Right, so yeah, you can see that I'm gonna change this to be hundreds. Okay, so that I'm done with the graph, that I need to show the bars. All right, okay, it is the revenue of this company, and in between just 0 to 100s. Okay, so now let's come back with the problem here. I want to talk about domain. I want to talk about range. You clearly see that domain in here will be just the how horizontal it go, right? Without how and then what's the range, how vertical it go without. And I'm gonna skip this one to let you guys book on that. Okay. All right, so this one also a okay, this is a problem talking about the profit function, and I want you guys to highlight this as profits will be equal to revenues minus cost. Okay, revenue minus cost. So so Bendy's Inc. makes paper clips and sell them. I mean, I was a little bit slow, and here the reason was I want the profit and revenues equal to revenue minus cost on the outside here better, right? Because we need this one for the all the function, all the information later. So, and you know that, to find the profit, you need to have the revenues, right? And you minus the cost value that you reduce. So then you're going to have the profit. Okay, so now come back with the problems. We have Bendy's Inc. makes paper clips and sell them at a price of P per 1,000 clips. So that means P is in here is a variables, unknown things. Okay, and then suppose that Bendy's profit function is given by P of x equal to 0.1 x squared plus 70x minus 10,000. Okay, so I would like to cross this because that doesn't make sense to me. Okay, so we don't need this information. All right, so we have profit function here, and we have graph here. All right, we can go ahead and according to from the graph, you can go ahead and tell me what is the domain, what is the range, right? So go ahead and put it down for me. Keep my that domain is how vertical is go. I mean how horizontal it go, and the range is how vertical is go, right? Okay, so maybe I'm gonna using here. Right. All right, so I also gonna skip these two and let you work on that. Okay, so I stop the 1.2 here, and we'll see you in 1.3.